All right, this is trig derivatives part 2. And basically what we're going to do for part 2 is we're going to take these new trig derivatives that we just learned in part 1, and we're going to go back and review some of the applications that we've done earlier in the year. So we're going to do questions like finding slope of a tangent line or equation of a tangent line. We're going to do some implicit differentiation. We're going to find extrema, which would mean of a graph finding the local minimums and maximums. And then we're going to do multiple derivatives, like I might ask you to find f double prime or f triple prime or something like that. So I'm going to do an example of a couple of those things with you guys. We're not going to do all 4, but we'll do 2 of them. So let's start with this question right here. It's an equation of the tangent line question. So we have our original function, y equals sine x times cosine x, and we want to find the equation of the tangent line when x is pi over 6. So we've done this question before. The only difference is there are trig functions in it now. We're doing questions we've already done this year and applying our new trig derivatives. So if I'm doing a tangent line question, the first thing I'm going to do is find the derivative. We have to find the slope and use the derivative to do that. So let's start off by finding y prime. Now when I look at my function, what I see is product rule. It's sine x times cosine x. So I'm going to do derivative of the first times second plus derivative of the second times first. Now the derivative of the first function, derivative of sine x is cosine x, we just learned that one, times the second function, which is cosine x, plus the derivative of the second function. Now the derivative of cosine x is negative sine x, times the first function, which is sine x. So we have y prime ends up equaling cosine squared x minus sine squared x. Now once you have the derivative, we can find the slope of the tangent, or m, by plugging in the x value, which in this problem is pi over 6. So if I have cosine squared x and x is pi over 6, basically that means is I want to figure out cosine of pi over 6 and then square it. And then I'm going to do the same thing with sine. Sine of pi over 6 and square it, we'll subtract the 2. So from the unit circle, cosine of pi over 6 is radical 3 over 2. Sine of pi over 6 is 1/2. Now when you square each one of those, you end up with 3/4 minus 1/4, which gives you 2/4 or 1/2. So our slope is 1/2. That's what we have so far. Now the other thing that we need in addition to slope is a point on the line. Now I know the point is going to be pi over 6 comma something because I gave pi over 6 in the question and we just need to find the y that goes with it. So to find the y that goes with it, we're going to go back to the original question and plug pi over 6 into that. So that's going to be sine of pi over 6 times cosine of pi over 6. It's the same two values we just used from the unit circle. Sine of pi over 6 is 1/2. Cosine of pi over 6 is radical 3 over 2. And when you multiply them together, you get radical 3 over 4. And that's what goes right here. So in order to answer the question, I'm going to use point slope form, which is y minus y1 equals m times x minus x1. And I have everything I need now. The 1/2 is m. The point is x1 and y1. Just put those numbers in and you're done. So for my final answer to the question, I'm going to have y minus radical 3 over 4 equals 1/2 times x minus pi over 6. And remember, you don't have to do anything with that. You don't need to multiply the 1/2 or anything like that. You can just leave it like that for your answer. So that was a quick review on finding equations of tangent lines. You use the first derivative, you plug numbers in to find the slope, you plug numbers in to find the point, and then you just have to know what to do with them. You have to use that point slope form. All right, the second equation I want to do with you guys, All right, The second example I want to do with you guys is implicit differentiation. Now, the reason I know this is implicit differentiation, really just by looking at it, is I have two different y's in the problem. When you have more than one function of y and they're jumbled up together like that, that's when you know you're going to use implicit differentiation. So when I go to answer this question, and we're finding dy dx, what I'm going to do is I'm going to take the derivative of everything. You're basically taking the derivative of both sides of the equation. Now on the left-hand side, we have product rule again. I'm going to leave myself a little space for that one. So it's the derivative of the first. Now we have an e to the x. We have to remember those derivatives too. The derivative of e to the x is e to the x times the second function, which is sine y, plus the derivative of the second function. So I'm doing the derivative of sine y right now. Remember, when you're doing implicit differentiation, if you're taking the derivative of a function of y, you take the derivative normally. So the derivative of any sine function is cosine, meaning the derivative of sine y is cosine y. But the reason I left myself extra space, when you're doing implicit differentiation, anytime you take the derivative of a function of y, you end up with that extra dy dx term there. And then we multiply that by the first function, which is e to the x, equals, and then now we get the easier part. On the right-hand side is just y, and the derivative of y is dy dx. So let's clean things up, move things around, get rid of the parentheses. We basically have e to the x sine y plus e to the x cosine y dy dx. I just took that e to the x and moved it to the front. And it's all equal to dy dx. So we've taken the derivative implicitly. Because we had two y's in our original problem, we end up with two dy dx's in our derivative. Now, what we want to do in this type of question, when you have that, take any of the terms that have the dy dx, group them together so you can factor them out. So what I'm going to do is I'm going to subtract this e to the x cosine y dy dx from each side. To cancel it here, and we get e to the x sine y equals dy dx minus e to the x cosine y dy dx. And now we can factor that dy dx out on the right. So I'm going to leave e to the x sine y here, factor out dy dx, and it leaves me with 1 minus e to the y cosine y. And finally, we are one step away from being finished. Once you factor out that dy dx, divide both sides by whatever is left over inside the parentheses to cancel that out. So I'm going to divide by 1 minus e to the y cosine y, because remember, when I do that, this whole thing just cancels out, and I'm left with dy dx. So this right here, this whole expression right here, is the answer to the question. That's dy dx right there. So that was a quick review on implicit differentiation. Remember, there's really two steps to this problem. Number one is actually taking the derivative, dy dx, and using implicit differentiation, knowing the difference between taking the derivative of a function of x and a function of y. And then you get that second half of the problem where after you found your dy dx, usually there's more than one in your answer, and you have to find a way to solve for dy dx. So you have to group them together, factor it out. All right, that's the end of part 2, and the assignment's on WebAssign for you guys.